Good morning, my YouTube viewers. It is Crystal here, and what I wanted to do is I want to give you a code review. This is a code review on, it says the Kaggle Cup Practice Contest Community Competition. And so what I did was I went ahead and did this competition. It's supposed to be a competition that's going to get you started in machine learning. And I used Tensorflow with it, and I created an artificial neural network. So we're going to go ahead and go over the code, and this is going to be one like to help you get you started in machine learning Tensorflow. You can use other models other than Tensorflow, but I'm learning Tensorflow at the moment, so I'm trying to use Tensorflow algorithms. So I ran the competition up, and the best score was 92.769%. And so I thought, well, the highest score was like 95%. And I thought, well, I can't get much higher than that. I don't really have a lot of time to invest in getting my scores as high as possible. Good for those people that scored higher than me, but I'm just using standard off-the-shelf models, and we're building models from Tensorflow, which is an off-the-shelf model. So since I don't have a lot of time, I'll just have to stick with the 92.769%. So we created the program in Kaggle using Kaggle's free online Jupyter notebook, and then this website, this Jupyter notebook is actually saved in my account. And what I will do is I will give you a link to the Jupyter notebook in the video, so you can look at it if you want. And so the first thing we're going to talk about is our problem statement. The task for this contest is to classify a mobile phone by predicting the price range with the value of 0, low cost, 1, medium cost, 2, high cost, 3, very high cost, according to the features. You do not have to predict the actual price of the mobile phone. So this is a multi-classification problem. So after we've created the program and we've read the problem statement, we know what's expected of us. We're going to import the library. So we're going to import NumPy as NP, which creates your numerical arrays, NumPy arrays, and does numerical computations. We're going to import pandas as PT, which creates series and data frames, and it does data processing. We're going to import OS, which goes into the operating system. We're going to import matplotlib.pyplot as PLT, which is your graphics visualization. And we're going to import Seaborn as SNS, which performs graphics visualization with statistics. Then what we're going to do is we're going to get the files that are going to be used. So we're going to use OS to do that, and the two files that they provide us with are train and test. So what we're going to do now is we're going to read those files using pandas and convert them to data frames. So train equals pd.read CSV, and then the web, or the URL for the train website, train CSV file, and we do the same thing for a test. We check train, and it's got 21 columns, the last column being the price range, which is the target, which is what you're going to predict on. And then we check on info of the train, so you can see all of these columns are either integers or floats, which means they're numeric. And then so that means that you don't have anything to encode. So we don't have to do any encoding on this data set. Check for any null values. We don't have any null values, so we don't have to worry about imputing any null values either. And now we check test. Test has 21 columns as well, And the difference between test and train is train has a price range column, and test does not have a price range column, but it has an ID column that train does not have. So we check to see if we have any null values in test, and no, there's not any null values, so we don't have anything to impute. So now what we have to do is we have to create our submission file, because they didn't give us a submission file in this contest. So we have to create our own. So submission equals PD data frame. Submission ID equals test pop ID. So when you pop the ID, what that means is that just takes the ID out, and ID does not appear in the data frame any longer. And if you'll notice, the ID in submission is capitalized, whereas the ID in test isn't. Now we're going to analyze train. We're going to use Seaborn to analyze train, and you can see that we've got 4 numbers of equal length, 0, 1, 2, 3. And then so we do a value counts on train price range, and you can see that each number has 500 examples to it. Now what I wanted to do was I wanted to see the number of unique values. So you do for call in train, print call, train call dot in unique, and that gives you the number of unique values in each column. So if I had wanted to, I could have made charts and things to represent the unique values, but I didn't do it in this occasion because a lot of the unique values were really high, and a lot of them were 2 unique values, meaning it was either yes or no. So I didn't do that, but I could have. I could have made done more of an analysis of the data set to determine blue. I think that means Bluetooth and dual SIM and 4G and things like that, and that would have told you how many instances you had Bluetooth and how many you didn't, how many you had dual SIM and how many you didn't. But I didn't do that in this one. I did do a heat map. Say core equals train.core, SNS heat map core, and you can see that the columns of data were not very highly correlated. So that's good, because the columns of data were not very highly correlated. I didn't have to remove any columns either. So now what we're going to do is we're going to define our x and our y variables. So y equals train pop price range. So what that does is that just takes price range out of train. And then x is train. So since I just made the decision to use Tensorflow, y equals PD get dummies y. So this is your PD get dummies y, 0, 1, 2, 3. Because we're going to be using softmax, and then when you use softmax, the label has to be one-hot encoded, and I just decided to one-hot encode it with pandas get dummies, and what that does is that one-hot encodes it. Now what we're going to do is we're going to split our data set up into training and validation sets. So from sklearn.model selection import train test split. So what we do is we x train x val, y train y val equals train test split, x y test size equals 0.1, shuffle equals true, random state equals 42, and then we get the shape of each of the little data frames that were created in addition to the test data frame. So now we're going into Tensorflow. So I decided to import my Tensorflow libraries and modules. I want to standardize the data. That's going to be the first layer of the model of the neural network that we're going to create. So normalizer equals normalization, axis equals -1, normalizer.adapt, np.array, xtrain, print normalizer.mean numpy. So that's all your normalized data, the mean of the normalized data. But really it's standardized. It says it's normalized, but really it's standardized. And then now what you do is we're just going to check to see what the values look like when they're not normalized and what the values look like when they are normalized, just so you can check and make sure they're normalized. Now what we're going to do is we're going to define our artificial neural network. It's going to be a sequential model. And then model.add normalizer, that's going to be the first layer of the model of the neural network. Then model.add dense 40 input dim equals x train dot shape 1, activation equals free flu, name equals hidden 1. Model.add dense y train dot shape 1, activation equals softmax, name equals output. And then we do a model summary, so you can see a summary of the model. So you've got normalization, hidden 1, and output. So now what we're going to do is we're going to optimize it. Optimizer equals atom, learning rate equals 0.001, and then we're going to compile it. Model.compile, optimizer, loss equals categorical cross entropy, and metrics equals accuracy. And so now we're going to train the data. So we're going to set it up for early stopping. So that means it won't run over, it won't continue running when it has no need to run. And then we're going to check the model checkpoint to select the best model. And so history equals model.fit, xtrain, ytrain, epochs equals 400, validation data equals xval, yval, batch size equals 32, and then we set it up for callbacks equals early stopping and MC. So you can see here we train the data. And we had early stopping at 158. And we had a val accuracy of 95. So now what we do is we make a little chart to see what the accuracy and the loss was. So accuracy is very close and the loss is very close as well. Now what we do is we make a prediction on the validation set. So ypred equals model.predict xval, and then you've got your ypred. I also could have done evaluate, model evaluate, but we just did predict. So this is your ypred. And then ypred equals np.argmax, model.predict xval, axis equals -1, ypred equals ypred flatten, ypred. So now we've got ypred after we've selected the number to put it on. And now what we're going to do is we're going to predict our next test. Prediction equals model.predict test. And there's your prediction. Prediction equals np.argmax, model.predict test, axis equals -1. Prediction equals prediction.flatten. And then here's your prediction. And now what we do is we prepare the submission. So submission predicted equals prediction. And one thing that they don't do is they don't tell you it's predicted. What you have to do is you have to go through and look at the tutorial. And then when you go through and look at the tutorial, they will tell you in the tutorial how you have to set it up. But so when I initially did it, I did ID and price range, and it failed. And then I thought, well, I don't know what's going on here. So I went and looked at the tutorial, and then the tutorial, it said ID and predicted. And so that's how I found out what you were supposed to do. And then so we're going to take the submission, we're going to convert it to a CSV file, and then we're going to read the CSV file, and then here's your prediction. And so what we do is when I submitted it to Kaggle, I got a 92.769%, and I decided just to stop at that point. I mean, what a lot of these people do who got more time available to them than I do is they just keep working on it until they get the highest score they could possibly get. But I don't have time to do that. So I try to get a good point and then stop. But then I'm able to make a code review for you, and I'm able to do the code review in a very logical fashion. So that concludes this code review. I hope that you got something out of it. This is like a beginning. It's a beginning machine learning example, but you didn't have to use Tensorflow. You could have used sklearn, but to use Tensorflow, because it's a multi-class problem, you have to set it up for get dummies for the y variable. You have to one-hot encode the y variable. So that's it really. I hope you like it. This is a good beginning machine learning example. I hope you like it. If you like my video, please like, subscribe, and share. Thank you to my subscribers for supporting my channel. If you want to be notified whenever I make a video, please tap onto the bell button and you'll be notified whenever I make a video. And thank you again for watching this video. I look forward to making more videos for you in the future.